Okay, now we're going from series to sigma notation. We're going to be given a series, and we have to determine what's the appropriate sigma notation. So a few different things we can do here. The first thing I would do is analyze the difference between my terms, or the ratio if it happens to be geometric. But this is arithmetic. We can see it's going up by 4 each time. Okay, that means we're multiplying these numbers by 4. So the first term is 2. The second term is 6. The third term is 10. Okay. So to get the full equation of what's happening here, we recognize that we are multiplying by 4. And we could do that just like this. Analyze the difference here. 4 divided by 1 is 4. So that means we're taking our, let's just call this the m value and not the n value. We're taking our m value and we're multiplying it by 4. So let's just look at the first one. We got 4 times 1, and it's going to give us an output of 2. What do we do to 4 times 1 to get that output of 2? Well, that would of course be 4, and then we'd have to subtract 2 to get down to 2. So that means we are multiplying our m value by 4 and we're subtracting it by 2. There's 2 here that have that equation. The other 2 do not, so we just get rid of them. Alright, now we just have to figure out, is this going to be 44 terms or is this going to be 45 terms? And to do that, well, you could list them all out and count, but I don't think that would be very efficient. I think a better way of doing it is looking at it like this. Take your highest term, 174, subtract the lowest term, which would be 2, and divide by the difference. Okay, so 174 minus 2 is 172. That over 4 is 172 divided by 4. That is going to be 43. You can use a calculator if you need to. What does that mean? That means after the first term, there are 43 terms. 43 terms. So if the first term counts as 1, and there's 43 after that, that means this would be the second, this would be the third, this would be the 44th. So this is our solution. So the first thing we do is we figure out what the difference is between our values if it's an arithmetic sequence. And then from there, do a little algebra chart, determine what we have to do after we multiply each of those by the difference. Then from there, we take the highest term, right, subtract it by the lowest term, and divide by the difference. Add 1, and that'll tell us how many terms there are in the sequence. Alright, let's look at another one. This one's a little trickier. Going to start out the same way. We're going to recognize, hey, this is going up by 3 each time. It's arithmetic. We're multiplying by 3, so it's 3k plus or minus something. And that means we can get rid of 4k plus 7 and 4k plus 7. So we're already down to a 50%, or I should say up to a 50% chance of getting this problem right. Now this is where sigma notation can be a little tricky. We could do the same thing that we did last time, where we say, okay, our k value, our first term is 7. We'll call that m. Our second term is 10. Our third term is 13. But you kind of get caught here because 7 to 10, that's going to be a difference of 3. There's going to be a difference of 1. To get the multiply number, the number you need to multiply by, you just divide the differences, which is 3, which we already noticed, but it's good to break it down algebraically. So then we might apply that and just apply it right here and say, oh, let's go with, we got to multiply 2 by 3. Oops. Got to multiply 2 by 3, add something, and you're going to get to 10. Well, 2 times 3 is 6, and that would be plus 4 equals 10. So, based on what we did last time, you might say, okay, I'm looking for 3k plus 4, which is not there. But, notice something different. They're saying that they're starting with the 0 term. So what they're saying is 7 is actually 0, and 10 is actually 1. That changes the game quite a bit, because now we've got to go back here, and now we've got to look and we've got to see, alright, we've got 0, 7, When the input's 1, the output's 10. When the input's 2, the output's 13. And we can do the same thing. We know this. We are going to be, again, taking 3 and dividing it by 1. So we're going to be multiplying these. But in this instance, let's go after 2 and 13 now. I'm going to take 2, multiply it by 3, and then add something and get to 13 instead. Okay, because we're dealing with a sub 0 term. Alright, so now we've got 2 times 3, which is 6. 6 plus 7 equals 13, and that is what we see here. So now we know that we've got 3 times k plus 7. The only thing left to do is determine if there's 35 or 36 terms in the sequence. And that we can do the same way. Let's do 115 minus 7 divided by the difference, which is going to be 3. Okay, 115 minus 7, that's 108. And 108 divided by 3. We can get a calculator for this. Okay, now that's going to be 36. Now, here's the interesting part. Last time we had to add 1 because we were starting at 1. This time, we're starting at 0. We don't need to add that 1. That 36 is going to be our total. So our solution here is this one, in case you can't see, is going to be 0 up to 36. The sum of that value, those values plugged into the expression 3k plus 7. So it's a little confusing, and you do have to recognize right away whether they're giving you the 0 term or the first term. Okay, go ahead and try this one on your own, and notice right away what they're telling us. They're giving us k equals 0, which means that 6 is a 0 term. Okay, I thought I'd help you with this in stages. So the first thing I notice is that this is arithmetic. It's going up by 5. So right away, because this 6 is the 0 term, I know that my equation for this is going to be 5k plus 6. So right away, we eliminate those two. Okay, then I take the high term, subtract it from the low term, and divide by the difference. And that's 121 minus 6 is going to be, oh my goodness, 115. And 115 divided by 5, I'm pretty sure is 23. Now, because we are dealing with a sub 0, that's the value we're going to. 23 is what we're going to. So that would be the solution right there.